Okay, so this is type 2 molarity problems. For type 2 molarity problems, you treat it as a simple stoichiometry problem. Furthermore, you use molarity as a conversion factor, meaning every time you see molarity, you're going to change it to a conversion factor where it's going to say moles of solute per 1 liter. As an example, let's say that they give you 2.6 molars. You would change it into a conversion factor where it's going to say 2.6 moles for every 1 liter. Okay? So here's the first question. Calculate the grams of hydrochloride needed to make 28.6 milliliters of a 1.6 molar solution of hydrochloride. Okay, so one of the first things that you should do is convert the 1.6 molar or whatever amount of concentration that they give you into a conversion factor, okay? So you're going to convert that and you're going to say 1.6 moles of hydrochloride per 1 liter, okay? It's just what we just went over a few minutes ago, referring to this part right here, okay? It's also over here in the top. All right. So now you have a conversion factor that you're going to be able to use whenever you do the dimensional analysis. Okay. The second thing that you do, you box what you're being asked to find. So it's asking us to calculate the grams of hydrochloride, which is what I have in here. This means that I'm going to have some type of number and that my units are grams of hydrochloride. I need to have this in my dimensional analysis somewhere in the top, okay? This is actually what I need to have at the end, correction, okay? And then my starting point is 28.6 milliliters, okay? So now that I have that, now that I know that, I'm going to go from 28.6 milliliters to grams because this is what I'm looking for, right? So I'm going from milliliters to grams. And guess what? You can find that here in your stoichiometry path. You're going to go from milliliters and then eventually make it to grams, okay? Either the left side or the right side that you use, you'll be okay. Okay. All right. So this is our starting point, and then we know that that the units have to match, right? Diagonal. So milliliters. I have 1,000 milliliters for every 1 liter. If you don't know that, it's also here in your stoichiometry path, okay? To be able to get from milliliters to liters, you have to use this conversion factor, which is what I have here, okay? Now, my units have to match again, diagonal. So liter and liter, okay? Now I get to use the conversion factor that I created a few minutes ago, which is this right here, okay? So liters liter, 1 liter for every 1.6 moles of hydrochloride. And guess what? You can also find it here in your stoichiometry path when you're going from liters to moles, okay? Because it's telling you to convert molarity to a conversion factor. Of course, it's not going to be this number particular, but it's going to be the number that you converted, okay? So now it's moles of hydrochloride, and now I'm going to have grams here, okay? So this would basically be the molar mass, which is basically this step right here. So we went here, 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 and then here, and then we're arriving right here, okay? So the molar mass is 1 mole, okay? 1 mole equal to the mass, okay? This is basically counting by weighing, okay? And from here, I know that I'm done because grams of hydrochloride are matching to what we were looking for in the beginning, grams of hydrochloride, okay? Everything else cancels out, okay, as far as the units go. And my answer is going to be 1.7 grams of hydrochloride. Okay. Now the next question: how many grams of pure methanol is needed to make 153 milliliters of a 1.60 molar aqueous solution of methanol? The molar mass of methanol is 32.04 grams per mole. Notice that they're giving you the molar mass, okay? And the density of methanol is 0.792 grams per mole. Again, what we do, we convert the uh, the molar number into a conversion factor, okay? So the 1.60 molar is going to be read as 1.60 moles of methanol over 1 liter, okay? We just made a conversion factor, and this conversion factor is going to help us do the dimensional analysis, okay? The next thing that we do, we box what we're being asked for, grams of pure methanol, grams of methanol right here. I know I'm going to have some type of number at the end. I know I'm going to have this at the end as well, somewhere in the top, by the way. And then now I have to find my starting point, okay? My starting point is going to be 153 milliliters, okay? 153 milliliters. So we're going from milliliters to grams, okay? Um, and then the reason that you know in this particular example where you're going from what point to what point, it's because they want you to convert to grams, right? And they're giving you milliliters, okay? So if you look here in your stoichiometry path, they want you to find grams. They're giving you a number that has to do with milliliters, okay? So it's going to be going from here to here and then up, just like the last one, okay? So this is a part where sometimes people get confused right here, okay? So 153 milliliters. I know that my units, they have to match diagonally. There's 1,000 milliliters for every 1 liter. And then I know my units have to match again diagonally. So liters and liters. And then I get to use my conversion factor that I created here, right? There's 1.60 moles of methanol for every 1 liter. Okay. And now I have to match my units going diagonally, moles of methanol. Okay. And then there's 32.04 grams of methanol. This information right here is actually given to you right here. Okay. Molar mass is this part right here, is this conversion. Okay. It allows us to count by weighing. Okay. Um, so usually for other products, you have to find it in the periodic table. But for this one, for the molar mass of this question, it was given to us right here. Okay, and if you forget what molar mass is, then just think about it for a second. Molar, mole, mass uses the units of grams. Okay, so with that being said, our answer is going to be 7.84 grams of methanol.